All right, y'all. So 7.4 for college algebra deals with quadratic equations, functions, and zeros. So quadratic equations. Now to be quadratic equations, the highest variable term is an x squared term. For the highest exponent, they all contain at least the x squared term. Now they can have the x squared term, the x term, and a number like a trinomial, or it can be the x squared term and a number, which is a binomial, and so on. But the highest variable term is the x squared term. That's what makes these quadratic. And remember, quadratics, when you graph, are going to give us the parabolas, okay? All righty, so the first thing we got to look at little terminology. So in this section, we talk about what we call zeros. So zeros are going to be the solutions of the quadratic equation that are obtained excuse me, that are obtained by setting the equation equal to 0. So I'm going to take my equation, set it equal to 0. Once I solve it, the actual solutions can also be called zeros, okay? Another thing about zeros. Zeros are equal to the x value of the x-intercepts. Of the equation. Or how about of the graph of the equation? And here's the thing, remember, we'll talk about this a little bit later in the support part, but x-intercepts are the x values on the x-axis. Remember now, if your points are on the x-axis, it has a y value of 0, okay? So that's why we look at the x-intercept, because that's where on the graph that the y values are actually 0.
Could you repeat that part? You said if it's on the x-axis, what again?
So here's what I'm talking about, these the x value of the x-intercepts. So say I had me a graph here. And we won't get too picky, but say this graph comes down and it's crossing my x-axis right here on the right side and right here on the left side. So let's say this point was on the x value of 3 and this one was on the x value of 2. So remember, if I'm on this line right here, what's the y value of any point on this line?
That'll be 0, right?
It'd be 0. So the x-intercepts of this graph would be -2, 0, right? You said the y value is 0 for that one. And then this one would be 3, 0. But what's nice is these solutions or the zeros, they're equal to these x values of these graphs. So that I would say, hey, my zeros or my solutions, well, look at these two x-intercepts. I get what, a -2 for the first one and a 3 for the next one. So if I can find where it has the x-intercepts, then I can find my zeros pretty quick. So yeah, we'll play with some of these. Now, what if a parabola's come up here like this? And this parabola does not even cross over the x-axis. So this parabola wouldn't have no zeros.
No zero, yeah.
Say again?
No, I was participating. I was going to say it wouldn't be no zeros.
No, it wouldn't be no zeros in the real world. But if I had an equation of a graph that made this parabola, guess what? Its two answers would be imaginary numbers. And remember, imaginary numbers we get from taking square roots of negative numbers. And I'll sort of go over that when we hit that later on, this quadratic formula stuff. But for right now, so that's how you get real zeros if they cross this x-axis, and these ones up here would be imaginary. So there you go. Because, you know, math people want to be able to solve any equation, not just in the real world, I guess. All right, y'all. So we're looking at quadratic equations. There's three ways I can start solve these quadratic equations. The first way, now remember, I'm looking at this, ax squared plus bx plus c equals 0. So it's quadratic because of the x squared term. And this one's actually a trinomial. It's got the x squared term, the x term, and a number. So the first way, if you can do this, solve by factoring. So to solve by factoring, you set this equal to 0. There's different forms of factoring. The different types of factoring could be pulling out a greatest common factor. It could be factoring a trinomial into two binomials. Y'all remember this stuff. The way you get these trinomials is by doing some FOILing. So to solve by factoring, you got to be able to factor those trinomials or binomials. Second method that's not too hard is solve by square roots. But sadly, I can only do the square root stuff if it does not have the x term in the middle. So cannot do if the x term is in the middle still. Okay, so the square roots only can have the x squared term and the number. Now, support when I do it, it does a lot of these by square roots. And then the third way. Now notice, I'm restricted on this one because I might not be able to factor the trinomial. I'm restricted on this one because a lot of these x squared equations do have the x term, so this don't work. But the one that'll work for every single one of those, y'all, is the quadratic formula. It'll solve any equation with that x squared term being the highest exponent. So everything's got to be on one side equal to 0 with the quadratic formula. So if ax squared plus my bx plus c equals 0, then the solutions can be given by, now y'all, here's the thing, let me explain this. When you got an exponent of 2, that's my highest exponent. Exponents tell me a few things. They almost tell me how many factors I'm going to have. But the main thing is the exponents will tell you how many answers we should get on these. For x squared being the highest exponent, I should get 2 answers on this. If that was the x to the 3rd as my highest exponent, then I would get 3 answers and so on. Okay, y'all. So this gives me my 2 answers for my quadratic equations. So here we go, y'all. X equals, well, let me let one in real quick. X equals negative b plus or minus the square root b squared minus 4 times a times c, all of that over 2 times a. All right, this is like a fraction. On top of the fraction is all of this, negative b plus or minus square root of b squared minus 4ac, all over 2a. So that negative going to change the sign of whatever RB is. That negative is always in the formula. This plus or minus, when you take a square root, so when you take the square root of a number, it can be either 2 positives that made that number, or it could be 2 negatives. So take 4 for example. Square root of 4 is 2, because 2 times 2 equals 4. But y'all, guess what? Square root of 4 can also be negative 2, because negative 2 times negative 2 equals 4. So that's why we use this little plus and minus. It represents the positive square root you can get, and it represents the negative square root you can get. Now, most of your work's going to be under here figuring out this part of the radical, okay? And then all this is all together divided by my 2a. Now, we'll play with this one in just a second. So I'm going to start going through how their problems are going to hit in 7-4. So this first one will sort of see how good y'all are at factoring. So number 1 will be some kind of factoring, and then the rest of these will be dealing with that quadratic formula, okay? All right, so my first example, find the zeros of the following. All right, so they're giving me f of r equals r squared plus 11r plus 30. So y'all, technically, the first thing I would do is take this and set it equal to 0 to get my equation formed. Because remember, this is just function notation telling me that r is my variable. So to get my actual equation set up, I would do r squared plus 11r plus 30 equal to 0. So the main thing on factoring, that right side must be 0. Okay. So any trinomial I'll get, I got to set it to 0. The only one that don't have to equal 0 is the square root stuff. So y'all, this is a trinomial. It factors in the 2 sets of parentheses. So this factoring undoes your FOILing that you did in the past. So look at the front of both these parentheses. That's this r squared. So what times what makes an r squared? Well, y'all, that's going to be an r in that parentheses and an r in that parentheses. So remember, x squared, I put an x and an x and so on. Now, y'all pay attention to this. This last sign right here, that's about to tell me two things. It tells me, the first thing it tells me is both these factors will have the like signs. They're both going to have the same sign. Okay. Second thing it tells me is it's going to want me to find factors of 30 that add to get 11. So y'all watch this. Let's put our signs in here. Last one's positive. So both factors will be positive like the middle number. So come down here and put 2 pluses. Now, remember this last number you get from multiplying this and multiplying this to get that last number. So let's think about this. What factors of 30 add to get 11?
5 and 6.
Oh, that was quick. So factors of 30 that add to get 11. And guess what? We know they're already both positive, so we can come in here and put in your 5 and your 6. Now, y'all watch this. You're all wondering about that 11R. Well, guess what? 5R and 6R add up to get the 11R. The 5 times 6 gives me 30. And then this R times this R gave me my R squared. So we are now officially factored. Now, y'all, here's the thing. If this was a minus in the middle, both of these would have been minus right here, okay? So this tells you got like signs, and they're both like that middle, okay?
So basically, what we just did was we just basically that's the answer. So we are basically, like you said, factoring. No, what am I trying to say?
Yeah, we
that
factored.
that first equation, we breaking it down basically.
Yeah, we factored it. We're going in reverse. So one
reverse. That's what I meant to say.
Yeah, last week y'all was in here going, okay, R times R is R squared. R times 6 was 6R, remember, 5 times R, and then 5 times 6 gave me 30, and y'all added the like terms and got this stuff.
Okay.
So we're going the wrong way now. We're going the other way.
So
Is it like unfoiling?
We're unfoiling. We call this factoring.
Okay.
So
Keep going.
we got 5 and 6, that, we'll call it, but gets 30. Is it always going to be like that? Or, you took the factors of 30 and got 11, and it worked out that way? Is it the way
I can't use
be, or
I can't use 15 and 2.
right?
Because 15 and 2 added to get what, 17? 10 and 3 add to get 13. 30 and 1 had to get 31. I had to use the two numbers that equal that middle number.
Right. So they'll always equal that middle number is what I'm trying to say. If you use
Oh yeah. And they'll multiply to get the last number, okay?
Right.
Are they gonna be small numbers like that, or is it gonna be like ridiculous numbers? Yeah, that's what I thought.
To say the truth, I guess that
Now
depends
get
on
an
how
answer.
much. That's going to depend on how much Mathmab likes you.
Great.
Some people that might give numbers like 30. Usually, if I'm getting small numbers, they're going to give y'all stuff probably maybe 20 something, 30 something, maybe smaller. I don't know. Mathmab's picky. But notice here, all we're doing, we just factored it so far. We haven't got our zeros yet or our solutions. So once we get these factored, we got to come in and set each of those factors equal to 0. Okay, so set each factor equal to 0. and I'm going to use the zero product rule. Zero product rule says if this factor equals 0, then anything you multiply by 0 is 0. Or this one could equal 0, and when I multiplied, equals 0. Zero's the only number that I can set these equal to that I know 0 is going to be a factor of, right? If something equal to 0, then you know for sure 0 has to be one of those two factors. So
Yeah.
that's why we set both of these, and this is how we're going to get those two answers I was telling you about. So y'all, I got an r plus 5 equals 0. Solve that. What I got to do?
Subtract 5 from
Subtract
both
5
sides.
from both sides.
Okay, so let's do that. R
The same
equals,
with the 6.
same thing, right? Good job. So here's the thing. These are my two answers. So MATLAB would have what? R equals blank. And you just come in, put -5, -6.
So we're gonna set it kind of like it's a y and x axis points.
Oh, now we don't have to graph these. I was just showing y'all, since these are the actual zeros of this, right here, -5 and -6. If I wanted to draw that parabola, or if I wanted to draw this equation, now y'all, next class, I'll show you how to find the points of the parabolas. But what I do know on this one is, here's -5 and -6. So let's go to -5 on this x-axis and -6. Since -6 and -5 are solutions of this quadratic equation, that means they're going to be the points where it crosses the x-axis at. Now, come Wednesday, I'm going to show you how to find this point called the vertex so that y'all can draw perfect parabolas. But these two answers are going to always tell me where it's crossing that axis at, okay? So it's not too
Before
bad.
you start this, can you please move the cursor?
What's the cursor?
Like
Oh,
your little,
right there.
yeah.
Okay. Oh, I didn't know
Thank
y'all
you.
could see my cursor.
Yeah, and it's bothering me. I'm sorry.
Okay, so let me just keep that up there. How about that?
Perfect. Thank you so much.
I never knew y'all could even see that thing, y'all. All right, y'all. Find the zeros of the following. So f of x here is going to equal x squared minus 14x minus 4. Now, if this one's going to be factorable, I'm going to set it equal to 0, because I always check to see if I can factor something first. Now, y'all, let me tell y'all this, just what this one would look like. Because remember, up here, my last number was positive. So if you got something in this form, I got an x squared, a negative number in the middle, negative number at the end. These will factor. Well, let's think about it. You had to multiply two things to get that negative. So what two things can I multiply to get a negative?
A negative.
A negative and a positive?
There you go. So if you got this pattern, two negatives, one's positive, one's negative. Just check it out. Positive times negative is a negative. Now, here's the thing about these. You find factors that subtract. Up here, that was positive. You found factors that added. Here, you're going to find factors that subtract to get 14 in the middle. Well, guess what? I've only got two guesses with that 4.
Hey, under that subtract, is that x squared minus 6x or bx?
Oh, that's a BX. Yeah. We're not playing with no numbers on it. This is just a pattern. If it's negative at the end, you'll have unlike factors. And the larger factor will have the same sign as the middle number. So since that middle was negative, the negative one will be my larger number. But look here. I got a 4 at the end. Well, the only factors of 4 is a 1 and a 4 and a 2 and a 2. Well, those ain't going to subtract and get 14, are they?
No.
No. So see, this one, factoring does not work on it. So y'all, if the factoring don't work, remember, I'm forced into using the quad on this one. So this one does not factor.
But are we still gonna use the quad though?
What now?
Are we still gonna use the quad out of the methods you showed us?
Oh yeah.
Okay.
Because if it don't factor, I gotta use the quad. That's my only choice. So it does not factor. We're going to use the quad. So remember, my quad formula was x equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. So our first goal is to get all of our numbers in. Now here's my equation. X squared minus 14x minus 4. First thing y'all got to tell me, what's a, b, and c equal? So what's the number of the x squared term?
Does that have to be 0?
What's that? So you got, so what number would be in front of the x squared term?
1x.
Oh,
1x.
1.
Well, or a 1. So I would, so a would be a 1. Good job. B is in front of the x. And that's what, a negative 14. And C is the last number that don't have a variable by it. So that would be negative 4. We got our numbers. We're going to replace this B with them negative 14s, A with 1, C with negative 4, and then that A with a 1. This negative in front of the B is always in the formula. The 4 is always in the formula. And that 2 on the bottom is always in the formula, okay? So I would come down and do my negative. So since my B is a negative 14, I'm going to put that in parentheses. So this negative's only purpose in life is to change this sign of this middle number.
You said the 4, the 2.
The 4 and 2,
what else?
they're always in the formula.
And what else again? There was one more thing that you said was it always in there too?
That negative.
Negative. Okay.
Mm-hmm. Now here's this plus or minus. This is how I'm going to get my 2 answers, remember? And then under this radical, negative 14 squared, because that's my B. Now the thing about this, whether this thing is negative or positive, when you square it, you better get a positive answer, because any number I square will be positive, okay? And then it's minus 4 times my A, which was 1, times my C, which is negative 4. So minus 4 times 1 times negative 4 all over 2 times A, and A, remember, was 1. So you plug in everything, there's no letters left. No letters. It's all numbers now. So the first thing, I'm outside this thing. What's this negative 14 equal?
14.
Okay, 14 plus or minus. Now I'm going to do 2 things in here. I'm going to figure out what that negative 14 squared is. So y'all on the side, negative 14 times negative 14. That's going to be 196. Now, do y'all see this right side of this? The -4 times 1 times -4. All of this is being multiplied. So let's think about this. -4 times 1 times -4. What sign will that have?
Positive.
Because I got two negatives, right? So that's going to make this positive. And then 4 times 1 is 4. 4 times 4 is 16. All that's under that radical at the moment on this side. And then 2 times 1 on the bottom
2.
gives me a 2. All right, so the tricky is going to be playing with this radical because I can't do nothing else on the outside until I get my radical figured out. So bring down to 14 plus or minus. All right, 196 plus 16. Oh, that's like 212. All of that over 2. So y'all, here's the thing I'm about to work on y'all with a little bit. Is simplifying this radical. Because 212 is not a perfect square root. And so you can go on your calculator. Oh, I didn't hook mine up, but on your calculator, you can do square root of 212. If it gives you a decimal, it's not a perfect square. So,
16.
So what we're going to do to this is we're about to learn how to simplify that square root of 212. So we're going to do side work with that square root of 212. All right, so y'all, let me make you a list here of what I call perfect squares. Perfect squares are numbers that I squared and got a product of. So I'm not going to do 1 because breaking out of 1 ain't helping me. But 2 times 2 was 4. 3 times 3 is 9. 4 times 4 is 16. Then I got 25, 36, 49, 64. What's next? 9 times 9, 81. 100. Square root 11 times 11 is 121. 144. So that'd be 12 times 12. 169. 196. And then finally 225. So this is 15 times 15. So the square root of 4 would be 2. Square root of 9 would be 3, and so on. But y'all, guess what? 212 ain't in that list. So that means 212 is not a perfect square. So to simplify this, to simplify a radical, we must remove any factors that are perfect squares from under the radical. So guess what? If any of these numbers are a factor of 212, 4, 9, 16, and so on, if any of them are factors of 212, I got to break them out, y'all. So here we go. Let's play with that. So the first thing you could do is 212 divisible by 4. So one of y'all got a calculator?
Yes, it is. It equals 53.
It gives me 53. So what I would do is write my perfect square 4 and then my 53. Now let's just see for a second to make sure we got the largest perfect square, because we got to get the largest perfect square out from under that. We got to look at that 53 that's left. Well, y'all, 53 will not divide by 4. It won't divide by 9. 53 won't divide by none of these numbers. It might give you an ugly decimal, but we're looking for stuff that divides actually evenly into stuff. So guess what? I got to break out this square root of 4. Now remember, square roots can be plus or minus. So y'all, what is the square root of 4?
2.
And then you're going to bring down that square root of 53. This is the simplified form of that square root of 212. Now, no other factors would have helped me. 2 and 106, that wouldn't help me because I can't take the square root of 2 and I can't take the square root of 106. One of my factors has to be one of these numbers, okay? So that comes down and becomes a 14 plus or minus 2 square root of 53 all over 2. All right, y'all. Now here's the thing. You see this 14, this 2, and this 2? If all three of these outside numbers have a factor I can divide them by, then I got to reduce these fractions. But notice I got a 14, a 2, and a 2. We can't mess with under the radical stuff, okay? Only the numbers on the outside. So these two numbers here will divide by 2. So the 14 divided by 2 gives me a 7 plus or minus 2 square root of 53s divided by 2. This leaves me 1 square root of 53. Now remember, I don't have a number here.
Hold on.
But in reality, y'all, it's like a 1 is up there, okay?
Okay, so go back one more time. When you said, okay, I got what you said. You said 14 divided by 2 got you that 7. But then did you basically cancel out the 2s and put the 53 down?
Well, basically, because remember, 2 divided by 2 would just be a 1.
Right.
And 1 times that square root of 53 was just that square root of 53.
Okay.
So here's what I would put in MathLab as. Now that's 2 answers in 1. So the first answer for that would be 7 plus square root of 53. And then your second answer would be 7 minus square root of 53. So the plus and minus on the square root is how I determine these 2 answers, okay? But y'all, like I said, MathLab will let you use the plus or minus. So that's sort of like shorthand for putting them in, okay?
So is it gonna ask for both of those answers then?
Oh, it wants both answers, but do this stuff. It's easier to put that plus or minus.
Oh, just put it all in the same problem. Okay.
Yeah, the plus or minus represents 2 of these in 1 because they're
Oh,
exactly
gotcha.
the same other than one's being added and one's being subtracted.
Okay.
So usually when the radical stays or the I stuff, then it'll be with the plus or minus. All right, let me turn this paper over. All right, y'all, let me move my camera back up. Okay. So same thing on this one. I got x squared plus 7x minus 5 equals 0. So remember, this one's negative at the end, so I would be looking for factors of 5 that subtract to get me 7. Well, y'all, guess what? That's not going to factor.
No.
So this one doesn't factor. So once again, we got to use the quadratic formula. So y'all figure out A, B, and C on this one.
A is 1,
Uh-huh.
B is 7, and C is 5.
He's -5.
Yeah, -5. Thank you.
Okay, -5. There you go. All right, so we'll just start plugging that in. So our formula will be x equals negative b, which is a positive 7. So all that negative did was turn this positive 7 into a negative 7 on this one. On the last one, it turned my negative 14 into a positive 14. All right, plus or minus square root. Well, b is 7. So it's going to be 7 squared minus 4 times a, which is 1, and c, which is a negative 5.
I have a question.
Uh-huh.
Is it gonna have that formula up on MathLab for those problems or no?
Oh, well, you'll probably just have it wrote down by you, okay?
Okay, that's what I needed to
Now,
know.
if you do the help me solve this or show me an example,
Yeah,
they'll probably pop it up for you.
okay.
Yeah. You'll know this before long because we're going to use this so much in this class.
Oh, I'm
Yeah.
sure.
You'll know it. All right, y'all. So that's going to make that a negative 7. So I'm bringing that down. Plus or minus my square root. All right, 7 times 7.
49, the square root of, yeah.
Uh-huh. Now watch this. You got 2 negatives on that side. So that's going to make that positive again. All right, 4 times 1 is what? 4. And that 4 times that 5 is a 20. So we got 49 plus 20 under there so far. And then on the bottom, we got our 2 again. All right, so now let's add this little stuff up under the radical. So you treat this radical like it's parentheses. We got to get everything done under that radical before we can try to get rid of the radical and try to start adding to this stuff, okay? Because remember, radicals don't add to these whole numbers or these integers because they're not what we call like terms. So y'all bring down that radical. So my last step under it would be to add that 49 and 20. Oh, what's that?
59.
69 over 2.
All over 2.
Mm-hmm.
So now I'm playing on the side here. I got a square root of 69. Are any of my perfect squares that I gave you a while ago, are they factors of that 69? Does it divide by 4?
No, it doesn't divide by 4.
How about 9?
Nope, it doesn't divide by 9.
What's next? 16.
Nope.
What's next? 25?
Nope.
We're starting to get too big, but one more I might would try 36.
Nope.
And y'all, everything else is starting to get too big to be a factor of that. So guess what? The radical does not simplify any further. So when the radical does not simplify, this point right here is our final answer. Negative 7 plus square root of 69 over 2, and then negative 7 minus square root of 69 over 2. So this little radical, it controls whether I can go further, whether I get real answers like this or imaginary with the eyes. So we haven't hit an imaginary yet.
Hold on, Mr. Eugene, before you go forward, can you tell me what again, how do you recognize if it's going to be a quadratic or if it's going to be solved by factoring, square root? Like how did you determine that by the
Well, I pray that they factor. How about that? Now, what makes it quadratic is that x squared term right there.
Got it. Okay, cool.
Now, it can have a number here or not, but it's at least, this has got to be the biggest exponent in it, okay? Now, I prayed that this would have factored because I could have just put it in parentheses and been done by setting them equal to 0 and stuff. But unfortunately, I couldn't find factors of 5 that would subtract and get that 7. And see, that's why, because it don't factor. That's why you got this radical answer. All right, y'all, so that was what, 7x? All right, y'all, the next one, they got f of x equals 4x squared minus x plus 9. So this one don't factor. Technically, since I got a number in front, I would multiply the 4 times the 9 and get 36. That product is what I would find numbers that added to get the middle, but that's a 1 in the middle. And 4 times 9 is 36, so there's not going to be any factors of anything that'll equal 1. So this one does not factor again. So that means I'm going to hit it with the quadratic formula, y'all. So set that thing equal to 0. And that's one of the most important things. You got to get them equal to 0. And then figure out, let's see what y'all got for my A, B, and C. All right, y'all, what A?
A is 4.
All right, how about B?
-1.
All righty.
And 9.
And 9. All right, so here we go. X equals negative B, which is -1, plus or minus our square root B squared, so that'll be -1 squared, minus 4 times A, which is 4, C, which is 9, all over 2 times 4. All right, so guess what? The double negatives, making that a positive 1 again. So that's going to give us our 1 plus or minus. All right, y'all, let's see what we're getting under here. -1 times -1 gives me a positive 1. So y'all, let me ask you this. All this stuff is being multiplied over here. What sign will I get?
Negative.
I'm going to get a negative out of that. Woo, all right, y'all. 4 times 4, I know is 16. 16 times 9. Oh, let me think. 16 and 9. I think I'm getting a what? 144 on that?
144, yeah.
Okay. And on the bottom, 2 times 4 is 8.
8.
All right, so one more step before I start trying to simplify that radical. 1 plus or minus. Look, y'all, look at that. 1 minus 144 gives me a -143. All of that over 8. So our side work is going to be playing with this for a second. We got a square root of a -143. Now, let me ask you this. When I showed y'all them perfect squares a while ago, were any of them negative?
No.
No. I can't multiply 2 positives and get a negative. I can't multiply 2 negatives and get a negative. So we cannot take the square root of that -143 in the real world.
So is that our
Okay.
answer?
Huh?
So is that our answer?
Well, in a way, but watch what we got to do. All right, here's what we got to do. Since this is negative under the radical, we're going to factor out a -1 over here. And we're going to put the 143 over here. This is the square root of -1 times the square root of 143. But if you multiply them together, they do still equal -143, okay? Now, can I take the square root of that -1? No.
No.
But what they said, well, we know we can't take the square root of -1. So we're going to replace that square root of -1 with this imaginary I. Now, let's play with this 143. Does it divide by 4? No, because that thing's odd. So try 9. No. So try 16. Y'all, you're going to go through all your numbers, but 143 will not divide by none of my perfect squares. So it's going to stay a square root of 143 under that radical. Now.
Okay, I have a question real quick.
I hear you.
Okay, so when you get to the side part with the perfect squares,
right?
You just use that with the perfect squares that you gave us.
Yeah.
So I'm checking all these numbers right here. But if any of them numbers are factors of that 143, then remember I got to pull them out like I did on the other side, I think it was. But see, like this 69 didn't simplify, so I left that as my answer. The 143 on this one didn't simplify. It won't divide by none of them numbers, but you at least, you got to pull out that -1 because we cannot take the square root of this -143 in the real world. So we bring that out and turn this into what we call imaginary numbers.
Okay.
Okay, so if anyone shows you, say, if I show you this, 2y. If I show you a 2y, that's really 2 times what? A square root of -1. It's telling me that the way they got that 2 was they took the square root of a negative number, okay? All right, y'all, so guess what? We're going to replace this. So if you leave this as a square root of -143, it'll mark you wrong because you got to pull out that I. So this would be 1 plus or minus I square root of 143 all over 8. Now, this one, since I got a real number, 1, and I got this imaginary number, square root of 143, you got to write this. Have y'all ever heard of a complex number? That would look like this, A plus BI, where A is the real part, BI is the imaginary part, which means we can't leave it as a single fraction. We're going to split this into 2 fractions. So the first fraction will be 1 over 8. Then we would put our plus or minus. For y'all, the second fraction will be I square root of 143 over 8. So both of the parts on the numerator are both divided by the 8 in the denominator. So look here. The 1/8 is what we call the real part, the A. The I square root of 143 over 8 is what I call my imaginary part. Now, you can put the I after your fraction if you want to. The only thing you cannot do with the I is accidentally put it under that radical, okay? If you put it under the radical, it'll get you. All right, let me do some more of these. All right, so this next one, they want me to find the exact answers, and then they want me to use approximations. I'm going to show you how. So let me pull my calculator up real quick. So let me pull it up, and then we'll knock out. This one wants us to find the approximation to 3 decimal places and the exact answer, which is with the radicals.
Is the approximation with that squiggle equal sign? With like the squiggles? Okay.
Yeah, if you see these.
Can you go back for a quick second?
Go back to
that other page.
Oh, okay.
Oh, okay.
Thank you.
Oh, that was it? Okay. So this is going to want both. So they're giving me 3x squared minus 5x minus 7 equals 0. All right, so A, B, and C. So
3, -5, -7.
okay. Now, since we're doing them by hand, we'll get our exact answers, and then we'll have to punch that on the calculator 2 different times using that plus or minus to get our other 2 answers that are approximations. Because y'all, if you got radicals left, those radicals, those are decimals that are never ending, okay? All right, so negative B will be -5 plus or minus B squared will be -5 squared minus 4 times A, which is 3, C, which is -7, all over 2 times 3. Okay, so double negative again, turn the -5 that was to be into a +5. All right, what do we got here? -5 squared. Under my radical, plus -5 times -5 is 25. Y'all look here, -4, 3, -7. Those 2 negatives will make that a
Negative
positive.
or positive.
Well, what do we got? 12 times 7. That's y'all getting like 84 on that?
Yeah.
All over 2 times 3, which is 6. So the last step for now is to add that and see what's happening to the radical. So 5 plus or minus square root. So that looks like 109 all over 6. Okay, so I'm looking and I'm like, I gotta try to do my side work with that square root of 109. Well, I know it ain't dividing by 4. It ain't dividing by 9. It ain't dividing by 16 if it don't divide by 4. Not 25. It ain't dividing by 36. Oh, that's what, 49? No, it's not dividing by 49. Starting to get too big. So this one does not simplify. So the exact answer would be this right here. This is the exact answer. Okay. Now, they want me to get the approximations. So we're going to have a first approximation. Then we will have our second approximation. Because remember, that plus or minus will give me the 2 answers. So y'all, what I'm going to go punch on my calculator first will be 5 plus square root of 1 over 109, all divided by 6. And now these approximations, we got to do 3 decimal places. Okay. So y'all, let me show you how I would punch this one on my calculator. So first thing I'd probably do is hit alpha y equals and hit enter on that ND, so it'll give me the fraction. So on top, I'm going to do my 5. I'm going to do the plus first. And then come over here to get the square root. You hit the second button and the x squared button and to pull up that radical. And under that, we got a 109. All right, now I'm going to arrow out from under the radical and go to the bottom. On the bottom, we had a 6. You know, if I arrow out to the right, there's our first approximation, 5 plus square root of 109 over 6. So y'all, I'm going to hit enter, and I need to go 3 decimal places. So that'll be 0.573. So I'm looking at the second 3 to determine whether I'm going to round up or down the first 3. Well, not down, but leave it the same. And so since that's a 3 followed by a 3, I'm going to leave that a 2.573. Now, same thing, but we're going to make that a minus or subtraction, okay? So alpha y equals, to get our fraction, hit enter. On top, we're going to do 5 minus square root, which is second x squared. Put in our 109. Arrow out of that, and then go to the bottom and put in the 6. So notice, they're pretty similar putting them in. The only difference is that plus and minus. So y'all, let's hit enter on this one. And I get what? A negative point. So y'all, you got a 9067. What's your estimation of 3 points?
906. I mean, sorry, 907. Because you said we're gonna determine if we're gonna round, right?
So since that fourth one was 5 or bigger, that turned that 6 into a 7. Good job. Whoops. Let me get back on the tablet. All right, so you're going to have one exact answer if you use the plus or minus on these. And then to get the 2 approximations, we just punched in the 5 plus 109 over 6, and then 5 minus the square root of 109 over 6. So y'all, that's your college algebra 7-4. So I'm about to do a little bit of support. So
hold on, Mr. Eugene. Can you put that back up there? Hold on, I'm so sorry.
Okay, let me see what side. That side right there.
Okay, give me just 1 second. So that's the 2 answers we'll put in for that one.
So they're going to say, what's the approximations? And there's always going to be 2 approximations. So that's how I got them. The first one I added, and then the second one I subtracted. And then on the exact answer, you could do this twice, write it out, but that plus or minus makes life a lot easier, okay? So I can write it once, but it still represents my 2 answers, okay?
Okay. Okay, I'm done, Mr. Eugene.
Yeah, so they're not too bad. You just got to get used to that plus or minus, okay?
But which one, I'm sorry.
I hear you.
But which one would lab want?
Oh, the lab's going to want all that on that problem. There's 2 problems. There's 2 problems where the lab says, hey, give me the exact answer. And then it's going to turn around and say, hey, give me the approximations to 3 decimal places. They want you to realize what the value of some of these are. Okay?
Okay.
And really, this big old, all this answer amounted to a 2.573 basically. Or if you subtracted that, because the square root of 9, although we don't know the square root of 109 because it didn't have none of them perfect squares, I know it would be in between what, 9 and actually it'd be in between what, 10 and 11, because 10 times 10 was 100, 11 times 11 is 121. So they're just wanting you to sort of get some values out of those and relate them to decimals. But y'all,
okay.
I ain't gonna kill y'all on that. Math lab, it likes to be cruel sometimes. All right, so this support is going to work over factoring, and it's going to work over the square root stuff I was telling you about. So for number 1, it wants me to solve 11a plus 5 in parentheses times 5a minus 15 in parentheses equal to 0. Well, y'all, guess what? It's already equal to 0 like I want. And it's already factored into 2 parentheses. So while ago, when I had the one that I factored, once I factored it into 2 parentheses, I took each of these factors and set them equal to 0. So you got 11a plus 5 is going to equal 0. And then this 5a minus 15, we're going to set that equal to 0. Solving both of these will give me my two answers. So we'll subtract 5 on our first equation, y'all. I get 11a equals -5. Come in and divide both sides by 11 because we want to make that a 1a. So the 11's cancel, giving me 1a like I wanted. Oh, y'all, we can't reduce that, right? 5 and 11. So that's going to stay a -5 over 11. So now that's one answer. So now we solve this factor. We'll have our second answer. So this one not as bad. I'm going to add 15. So 5a will equal what? 15. And divide both sides by the 5 to make that a 1a. So y'all look at that. That's going to give me what? A equals a 3. So my two answers are -5/11 and 3. Now, MATLAB will have the solution is blank, put one in, then a comma, then the other one. Now y'all think about this in the future. We're going to start with these answers right here in the future. We're going to work backwards and get something like this. And then we're going to FOIL this stuff and come out with an actual trinomial. We're going to actually find the equations that these answers come from.
Sounds like a blast.
Oh, you're going to get excited, girl, when you do that. It's fun when you go backwards and forwards. I'm just messing with y'all. Here we go. No, but we really will go backwards. That'll be around section 8.4, okay? So let's see, 8.4 will actually be on our third test. So you got a little bit before we hit that. All right, y'all, here we go. C squared minus 7c minus 30 equal to 0. Now, this is your support stuff, so they always start with the earlier steps until they hit this trinomial. So we just played with some of these, and I'm about to see if y'all remembered. Set two parentheses up, because that's a trinomial. It's going to, if it factors. Now, here's the thing. There's only one, I think, you got to do the quad stuff to in the support, and it's going to be the last one.
Is that 2 minus 7c?
C squared minus
Oh,
7c.
c squared. Oh, okay.
Minus my 30. So I got a c squared. What's going in front of both parentheses? Well, y'all, it's got to be a c, right? Now, the last sign is negative sitting there. So remember, what signs did I say I'm putting in here if that was negative?
Positive and negative.
So we got one of each, right? Anytime that's minus, make one positive, one negative. All right. Here's what I need from y'all. I need me two factors of 30 that'll subtract and give me 7. See how I'm reading right to left? Factors of 30 that subtract and give 7. All right, all right, so give me two numbers that'll multiply and get me a 30. So 1 and 30, but they don't work. What's next? 2 and 15 don't work.
5 and 6.
5 and 6, but do they subtract to get a 7? Now, I thought I heard someone say the actual
10 and
number.
3.
Is it 10 and 30?
10 and 3. Well, y'all ain't 10 minus 3 is 7.
Oh yeah, and 10 minus 3. 10 minus 3 equals 7.
So remember, anytime this last one's negative, I'm looking for numbers that subtract to get a 7. Now, guess what? 10 and 3. The larger number is going to be negative like the middle. So the larger number is negative like the middle. And y'all, 100% of the time, the larger number will always have the same sign as that middle number. So the 10 would be negative and the 3 is positive. Because remember, 3 and negative 10 got to add to get that negative 7. And then that 3 times negative 10 has to equal that negative 30. All right, y'all, so let's see. We solved it that part. Now we got to set the c plus 3 equal to 0 and the c minus 10 equal to 0. So I'm going to subtract 3 on this one. I get my c as a negative 3. Over here, we'll add our 10 and get c as a positive 10. So we got our 2 answers and we're happy, so we can move on. So y'all, here's one like I was saying a while ago. So this says solve by factoring again. 3t squared. So 3t squared minus 13t minus 16 equals 0. So here's what I was talking about a while ago. So this one does have a number in the front. So the first thing we do, we're not looking for factors of 16 that'll give me 13. The first thing we got to do is multiply that 3 times 16. And y'all, 3 times 16 gives us 48. Anytime you got a number in front of the t squared other than 1, you got to multiply the first and last number. Now, what I need now, I'm going to set this up as parentheses. Ignore the 3 for the moment. The t squared, that means I'm going to have a t and a t. Okay? T and a t. What signs am I putting in here? Well, I'm focusing on that negative at the end.
I got a question in just a second.
Uh-huh.
I guess I kind of lost, why did you multiply 3 times 16 to get 48?
Because remember up here I had a c squared.
Right.
And that was just a 1 there. So when you multiply 1 times 30, you're not changing anything. But right here, if you got a number in the front, we got to multiply it by that last number to get, this is what we're going to find factors out of, is this 48. And we're forced to do that because this is not a 1 up here.
Okay.
So what y'all got to do for me? Now, what signs did y'all say to put in here?
Plus and minus.
Plus and minus. All right. So y'all, factors of 48, that'll give me a, remember they got to subtract and get 13. So 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. All these are ways to get a 48. What set will give me a 13 when I subtract? Hope y'all are picking
16.
at 16 and 3, right? 16 minus 3 gives me 13. Y'all be careful. Sometimes it's the same numbers you started with, okay? Now watch this. Of that 16 and 3, what signs is 16 going to have?
Negative.
And that means the 3 will be positive. Now, y'all, here's the difference between what I did right here on this one. Since I borrowed that 3 to multiply by the 16 and get the 48, once you got the two numbers, you got to divide that 3 back out of them.
Hold on, why you gotta divide them back out again? Because of what?
Because we borrowed it when we multiplied by the 3 here. We did 3 times 16 was 48. So
Okay.
at this point, you got to divide both by the 3. So if you borrow that first number like we did to get a product, right here I did 3 times 16 to get my 48. Well, right here, I got to divide it back out. Now watch this. Can you simplify this fraction?
I don't think so. Let me see.
Y'all got a 3 divided by 3, which is
1.
1. Can we simplify that 16 over 3?
No. Well,
No, so
no.
that's going to be t minus 16 thirds. All this equal to 0. All right, y'all, so watch this. Set both of these equal to, we pretty much got it factored here. Okay, so we're going to set both these equal to 0. So y'all, the first one, t plus 1 equals 0. You got one move. We're going to subtract 1 from both sides so that I get t equals -1. Right here, I got t minus 16 thirds equals 0. So I got to add 16 thirds to both sides. And guess what? I get t equals 16 over 3. So basically, once we got it to the point where it's factored, I'm changing the signs on that is all. So that's going to be your trickiest one. And thank God these ain't on the test like this one, okay? Now, let me ask y'all this. If you don't like factoring that, what could you have used? What did I say worked every time?
Quadratic equation.
Quadratic formula. So if you don't like this factoring, you could use the quad formula.
For that whole problem we just did, we could have used the quadratic formula.
Oh yeah, A is 3, B is -13, C is -16. Plug all that in, and guess what? You would have got these two answers.
Okay.
All right, so how about something a little nicer than that problem? So let
Yes,
me bring it
please.
back up. So at 4, they started doing this kind of problem. Solve 4x squared minus 28 equals 0. So do y'all remember what I said I could do if I had two terms being subtracted and it didn't have that x term in the middle? And I gave us 3 ways, right? We done the factoring already. We done the quad. So the other thing we haven't used yet is the solving by square roots. So I'm going to solve by square roots. Since there's no x term. Now you see an x here, but that's an x squared term, okay? X was the number in the middle, and we don't have one of that. So if we don't have that, we're going to do this a little bit easier than we would if this was the quad, okay? Or factoring. So y'all watch this. To solve by square roots, we got to get this x squared on one side by itself. So we're going to add 28 on this one. Now, you could do the quad to this, but woo, that'd be a lot more work than you need for this one because the 4x squared is coming down. That's going to equal a positive 28. All right, one more move I would do, divide both sides by 4, because we want to get that x squared by itself with a 1 in front of it. So then I would do 28 divided by 4. So y'all, those 4's cancel. I got my 1x squared. 28 divided by 4 gives me 7. So now, how can I turn an x squared into an x? Well, guess what? Y'all remember when we was doing the inverse functions? If I want to turn x squares into x's, I take square roots of both sides. So at this point, we're going to take square roots of both sides. Square root of x squared will equal the plus and minus square root of that 7. All right, so remember, square root cancels the exponent. So all that's left on the left side is my x. So remember, that cancels with that exponent. Bring down that plus or minus. So we're playing with this 7 now. There's a square root of 7. Does it divide by any of those perfect squares? So does the 7 divide by 4?
No.
And, well, hell, that's the only one smaller than 7. So guess what? That doesn't simplify. So my final answer will be a plus or minus square root of 7. So the square roots are quicker to get to them answers. You could have plugged all this in the quad formula, but y'all, that's a lot more work. Try this one.
Hold on. When you put it in, you put in x equals plus or minus square root of 7, correct?
Yeah, you should only have to put in that part right there. Usually
Okay.
they'll have the x equals or they might say the solution is or whatever on it. So,
Okay.
all right, y'all, 3x squared equals 6. So notice, there's no x term in this one, right? So I'm going to solve by square root since there's no x term. So the first move I would do to get this to be a 1x squared.
Divide by 3.
All right, so that's going to give me my 1x squared over here. And let's see, that's going to equal 2. All right, I need to turn that x squared into an x. So square root each side. And remember, that's going to give me a plus or minus on that right side. So y'all, let's see. Square root cancels the exponent, leaving our x. We know it's going to be plus or minus. So can we do anything with, well, y'all, 2 is smaller than my smallest perfect square, right? So that's just going to stay what? A square root of 2. So this is what we want to put into our math lab. All right, y'all, let's try this one. 5x squared plus 10 equals 0. So, first move. Okay, so you're giving me what, a 5x squared equals, that was a negative 10. All right, and then divide by that 5. Y'all, let's see, we get our x squared equals, that's going to give me a negative 2. So we're at this point now where we're just going to take them square roots. So we know that'll be a plus or minus square root of that negative 2. All right, y'all, so we know this is going to give us x. The radical cancels the exponent. We know this will be a plus or minus So y'all, can we do anything with this square root of -2?
Oh,
Oh, I thought I heard a no. Y'all said a yes, didn't you?
no, you can't do nothing with it.
Oh, y'all can't do nothing to that?
Mm-mm.
Oh, I bet there's one thing y'all better do to that. Remember, what did I say if it was negative under that square root?
You have to square root it by -1 and 2.
Bam. You at least, there you go. You got to break out that negative as a and what did we say the square root of -1 was?
Did you say I?
I. So that gives
I?
us the I and then our square root of 2. So that our final answer will be plus or minus I square root of 2. Or you could put square root of 2I. Remember, just don't put the I under the radical, okay? So y'all, if it's negative and you do square roots, you're going to get them imaginary answers, okay? All righty, so let me try. This one's not bad. Solve x squared plus 81 equals 0. So we'll probably just do 7/4 support. I'll wait till Wednesday to do 4/8. But I want to cover all these ones. Whoops, y'all don't even see my problem. Here we go. All right, so x squared plus 81 equals 0. So here we go. We're going to subtract 81 from both sides. I get x squared equals a negative 81. So now we're going to take those square roots. So y'all, here we go. That's going to cancel, giving me my x. And I know this will be a plus or minus. Well, y'all, that's going to be a plus or minus what? Well, the first thing we're going to do is break out that -1.
It's gonna be a plus or minus I square root of -81. I mean,
Well,
81.
what's the square root of 81 though, man? I think that was in my perfect list, wasn't it?
Oh yeah, it was. It's 9.
9.
It's gonna be I9.
There you go, I9. Or usually by what do you call it? By tradition, I would probably put a plus or minus 9 there.
Oh, 9. Okay.
Yeah, it should take it either way, but by tradition, when you got just a number in the I, they just like them usually put in numbers in the I.
Okay.
So square roots of negative numbers that are perfect squares comes out as that number and the I.
And the I goes behind the number. You have to do the number first.
You could probably do like this right here, plus or minus I9.
It's weird.
But usually they'll put the number first because if you was adding like a 9I and a 3I, they sort of like to keep with the numbers first because the I's would be the like term part.
Okay.
Almost like the variables and stuff.
Right.
All right, y'all. So we're going to draw a little graph right here. And this will be my last one. So I'm just going to go out 5 each direction. Also, y'all, this one with the plus or minus 9I, that would be one that was either up here that didn't cross the X, or it would be turned upside down and wouldn't be crossing it. All righty. So say I got me one of these parabolas. It's crossing right there. And this side is crossing right there. So it's more toward this side. So say it just comes down, hits and goes up. First thing I'm going to want are the x-intercepts of that graph. Then I'm going to want the zeros. So remember what we said when we had graphs of them. So y'all, what's my first x-intercept?
-4.
-4 and 3.
Well, remember, I'm doing an x-intercept, so that's going to be -4. What's the y value of that point?
0.
Okay, then you're going to close that. Remember, the x-intercept's got to look like a point. So what's this x-intercept then?
3.
3 and 0.
Okay, so remember, MATLAB on the x-intercepts, you got to put them as a point. Now, the zeros, boom, boom, what are those?
-4 and 3.
I thought I heard something, but I couldn't hear.
-4 and 3.
Okay, remember a while ago we said, well, the x-intercepts give you where it crosses the line, which is also the x values. Okay, so those x values of the x-intercepts is my zeros, because remember, that's where the y value is 0 at, okay? And we're setting all of our equations equal to 0. So that's main thing. Now, support will have one of those upside down, but it's the same thing. Find the x-intercepts, and then the zeros will be the numbers. And then I think it ends up with a quad, but we've done the quad like, what, 6 or 7 times. So we're good on a quad. So let me see here. Yeah, I'm going to say 4-8 till next class. Because it's working on a little bit of foiling and solving equations still. But we're going to wait on that one till next class. So all that y'all got to do tonight is my 7-4 college algebra and support.
Okay.
Now, y'all should have got it. I'm going to stop my share. Y'all should have got it emailed out of me today.
Yeah, with the bonus work.
With the bonus, okay? So there's a bonus opportunity for y'all up to 10 points, okay? So here's the thing. The highest grade I can give is a 105 on the test. So say you made a 98, 99, and you did the bonus, I would only add enough points to make it a 105, and then the rest, I'll throw on a review or something else. Okay? The highest I can make a test is 105. So if you had like a 95 or higher and you do the bonus, that's the highest I can go. And it's what, 3 questions I gave you that were sort of like questions on my test. Okay. And I think I got it due by Sunday night. So if you made, say, a 70, which is a C, and you want a B, do the bonus. The bonus has the power with 10 points to pull you up at least 1 letter grade, okay? So 7-4, you got your support and your college algebra. And then you got a bonus that you can either text me at the number I gave y'all and scan it, or you can do it in a Word document and send it through email.
Okay.
Oh, I guess I was actually recording all that. Okay, that's cool.